Hello students, welcome back. So we have a battery, we have one resistor and one LED. We are connected it to 9-volt battery. So this battery, resistor and LED, these can be represented by circuit symbol. So today we are discussing about the source potential difference or voltage that is represented by a battery. So what is this battery? This battery is a supplying voltage and it is represented by a symbol like this. There is one plate having more length and there is a small line having less length. So let us focus on this battery, how exactly this battery works. We have electron, we are saying that electrons generated at a negative terminal and they come back to the positive terminal. Then what happens inside the battery? That we have to discuss. Let us continue with that. So we will focus on the battery. This is our symbol. One is positive, right side is negative. So what happens inside that? There are two plates. These two plates are considered as say electrodes, and along with that we have some kind of electrolyte. That is a chemical. You might have studied the process earlier. So then we have one positive, one negative ion. So there is a chain of positive and negative ions inside the battery. We are talking about the inside view of the battery where positive and negative ions are there. Due to this chemical process, what happens? These positive and negative ions, they get attracted towards the different plates. So one plate becomes positive, another plate becomes negative. So we get some chemical force. We are representing it with some parameter Fc. This chemical force sends few ions to positive plate, the positive ions, and few ions to the negative plates. These are negative ions. Then what happens? We have two forces here. One is the chemical force inside the battery and another one is the electric force, electric field. What we are talking is capital E, say that is electric force. So along with Fc we have one more Fe. So what happens when we apply Fe? And if the chemical force Fc is greater than Fe, what happens? There is more force on these ions to move toward the plate. So we get more movement. And when they get equilibrium, when the both forces, the chemical force and the electric force, Fc and Fe, they becomes equal, then what happens? The complete plate is covered with the positive and negative ion. There is no more space for covering the ion. They become like a wall on two plates. Then these are the walls of two plates. What happens with the movement of electron? So if we get one electron and we want to push it, what we say, electrons get generated at the negative terminal. Some force is working inside the battery. That is called as electromotive force. Electromotive force exists only inside the battery. Electric field is applicable for the entire circuit. The direction of electric field is always from positive to negative. Suppose we have some electron. So what happens? This electromotive force gets some electron at the negative terminal. So what happens? They are similar. So similar having repulsive force. They don't want electron to be there. So if there is one electron, what they do? They give some repulsion. They throw it away, and that electrons go away. They are pushed into the conductor. Then what happens? That electron rotate in the circuit and come back to the positive terminal. So we get the electron at positive terminal. What happens at positive terminal? If electrons are coming and gathering there, then the positive ions, they reduce. The positive charge try to reduce. Then what they do? They try to push it towards the circuitry. Then again they reach to the negative plate, and negative plate again send it back to the wire. So continuously there is movement of electron inside the circuit. Say there is some distance between these two plates. So electric field intensity is work done per charge. So the voltage is work done per charge. Here this E or epsilon, in few books it is given as epsilon, represents the electromotive force. There is also kind of voltage, because its formula you can see it is same. Work done for charge. But where this work is getting done? This work is getting done inside battery only. If the work is done inside battery, it is termed as electromotive force. And if work is done outside the battery, it is considered as the work done per charge is voltage. So here we can see, so we have negative charges generated at negative terminal, they rotate, again they come back to battery, again electromotive force is applied and they rotate. So like this we get the movement of electron. So again we will come back here and we will see what is the difference between electromotive force and the voltage. So first thing, electromotive force exists inside battery only. So it does not exist outside. So inside battery EMF acts, so that is the symbol of battery. And where do voltage is applied? It is applied to the loads. What is meaning of load? Load is something which is using the current. At your house, if fan is rotating, so fan is the load. If your television is working, that means television is your load. He is taking that current and he is consuming that. And whenever there is usage of current by particular load, there is voltage drop between the 2 points. So here the one point of resistor is say at the top, another at the bottom. Between these 2 points, there will be voltage drop. So these voltage drops are present for the different elements who are consuming the current. Resistor is consuming the current, your LED is consuming the current. So their work done per charges is voltage outside the battery. Inside battery it is for EMF. We will see few more differences of between the EMF and potential difference. EMF is defined as work done on unit charge. Potential is also defined as the dissipation of the work per charge. EMF remains constant. Electromotive force is always constant inside the battery. But voltage is not constant. It depends on, say, resistor. We have Ohm's law. What is Ohm's law? Say, we have current I is equal to V by R. So what do we say? If current is increasing, resistance decreases. If we increase the resistance, the speed breakers, then what happens? Current decreases. From here we can say V is nothing but I into R. So this is directly related with the resistance. Voltage and resistance are directly related. Voltage depends on the resistance. So its value is not same, but EMF is same and it works only inside the battery. EMF is independent of circuit resistance. Due to EMF, electric, magnetic and the gravitational field is caused. EMF is the larger force. It is multidimensional force. We will see in the consecutive classes when we get the reference that electromotive force can generate even magnetic field. But voltage can create only electric field. And the direction of electric field is always from positive to negative. Then it is represented by E or epsilon. Capital E we also use for the electric field, so we should not get confused. So we let us use capital E for electric field or electric field intensity. It is given by work done, electric field intensity is force per charge and will represent electromotive force with say epsilon, and voltage is represented by V. So this is about the difference between electromotive force and the voltage. Now what are the sources of voltage? Voltage is not only present in the battery what we have discussed yesterday. We have seen the batteries. So say we have one 9-volt battery what we use. This is some DC supply, 9-volt DC, but this is not the only source of voltage. What we get voltage at home, that comes from some stations. We may have the projects where we get the electricity generated, the big projects that generate, say we can use wind, we can use water, we can use sun rays to generate the electricity. That electricity is AC, that is alternating voltage. What we get in the battery is DC. So there are various kinds of sources of voltage. At home we get AC 230 volt. So these are the symbols. If we are using a battery and there is a single cell you might have seen in the watches, a single cell battery, and multiple cells, the battery, like the 9-volt battery is a multiple cell, we will see in the diagram. If we are using DC voltage, we can use this symbol. If we are using AC, we have to show the sinusoidal sign. What is meaning of AC? AC is alternating. Alternating means which is continuously changing with respect to time. So we represent that change as a sine wave. So this is AC voltage. Here suppose you are using 5 volt battery. In mobile phone you may have 3.3 volt or any other battery. If you use 5 volt battery, it can be represented like this also. We can represent like this also. So we have one circle, positive and negative, that is DC source. For AC source, suppose if we are using 120 volts AC volt, VAC means volts, AC volts. Here 5 volt DC. Then we can represent it with some sinusoidal symbol. So we can have AC source or DC source as per our requirement. The example is like if you are taking 230 volt AC at the home, you are plugging your charger and connecting it with your mobile. Mobile require only the DC current. So what we have to do, we have to convert AC to DC. That is done in the battery. That task we will give you. So here what we have? We have a battery. In battery, we have electromotive force. What is that electromotive force? So there is some kind of voltage in that, and there is some internal resistance of the material. Every material have his own resistance and he consumes the power unnecessarily. So we have to consider the material resistance or internal resistance. So here we are using small r for the internal resistance. So how we can take the voltage between two terminal of battery? Inside battery we have one E, that is electromotive force. So electromotive force, that is the chemical force, minus IR, the drop, the current used by internal resistance. Internal resistance is not visible. It is due to the material. Material causes some losses, that is termed as the internal resistance. This is not visible. This is inside the battery. We are representing for understanding. And similarly, if we have two cells, multiple cells. So multiple cells will have one electromotive force for one cell, and there is one more electromotive force for the second cell. For this expression we can get. Now what are these multiple cells? What we are saying, if this is a cell, there are multiple cells. They are connected by cell. How are these cells? These are the cells. And if you open the covering of this battery, you will get like small cells, circular cells are connected on each other in series. So there we represent only this single cell. This is also single cell. And like this, there are several cells inside this big cell. So that is multiple cell. So we can represent it like this also. So in multiple cell, there will be multiple electromotive forces and multiple internal resistances. So here, if we have two cells inside the battery, we will have one electromotive force for the bottom cell, and we will have electromotive force for the top cell. And R1 and R2 are the internal resistances for cell 1 and cell 2. And this is the load connected. It may be bulb, fan or whatever. So this is also one example where battery charger is used. This battery charger is connected. There we have the chemicals and all. Usually the bigger chargers we are used for the vehicle batteries. So let us have the glossary. What we have discussed: electromotive force, the potential difference of a source of electricity when no current is flowing, measured in volts. Internal resistance, the amount of resistance within the voltage source. Potential difference in electric potential, it's the difference between 2 points in an electric circuit. Terminal voltage, the voltage measured across the terminals of a source of potential difference. So we have to remember these things. So what is your assignment for this part 2? In part 2, you have to explain the difference between electromotive force and the voltage. You have to write it on a paper and upload it on the given link. So have a good day and read this quote from the Albert Einstein. So imagination is more important than anything else. That is a very powerful statement. You have to think about it. Have a good day.